The topic of discussion is image formation by a plane mirror. So before we talk about image and all of this, basic question. When do we see something? Or how do we get to see something? Basically, the object which we want to see either has to have its own source of light. If not, we can have a source of light around it. So what happens? Light falls on that, bounces off, and we get to see that. That's the basic idea, is it not? Now, if I want to see an image, I need to understand where the light is coming from. Okay, so here I have an object, I have a mirror, and this is where I have a camera through which I want to see. So let me indicate the mirror, which is reflecting and which is non-reflecting. So this is an object which has its own source of light. So it's radiating out light in all the possible direction. So there are n number of rays, uncountable. So to get to understand where do we see an image, right? Plane mirror, we see the image kind of behind the mirror. Not exactly, I mean, technically it's not so, but yes, we feel so. So for that, I need to at least have two rays from the object, which falls on the mirror. It can be somewhere over there, there. I already picked two, so I'll just choose this itself. Okay. And after that, we know what happens. It will bounce off. But again, here too, we need to obey the law of reflection. So I need to draw normal and everything. So for that, I need compass, which I have over here. Just a second. So I have compass and everything. So let me pick it up. Okay, I hope I'm right. Let me zoom in. It's good enough. Now, how do we have the normal? It is perpendicular to the mirror. So this makes sense. So then we need to measure the angle. It's around 41 from this side. Of course, we should be measuring from this end. So 40 minus 90 is 50, 49 degree. So this end too, the same thing should be there. So we'll end up with something like this. Okay, so this is your incident ray. That's your reflected ray. So this too is your 49 degree. So one ray won't help. We need at least minimum two rays. More than two is good enough. You can have more than two, not an issue, but it should not be less than two. Oh yeah, sorry, I can't do that. So here too, I need to use my protractor. Okay, so measure the angle. First thing is the normal. So let me draw the normal. Yes. Then measuring the angle. This is around 60, 61, 62 degrees. Okay, this end too, we need to have 62. That is around, it will again go to 28. So here we're looking at 28. 28, yes. Right, I hope I'm right. Okay. So this is 62 degree again. Incident ray, reflected ray. So still I have not answered. Where do we see the object? Where do you see the image? So for that, I need to trace back this reflected ray. See, these two rays are going away. So they are diverging. We already learned about converging and diverging. So these two are going away. They won't meet further ahead. They appear to meet at the back. So for that, I need to trace it back, in this way. Okay, always trace back along the line, coinciding the line of the reflected rays. people, everything else they do. I've seen students doing this, but the last part they miss out. So trace back. Okay, exactly. So I might not get exact one over here. I hope I got, but yes. So the point they meet, right? That's where the image is, right? This is where the image is seen. That's it. As simple as that. Okay. Technically, if I have done it right, this should be in the same line kind of thing. I am off by some degree. I've done something wrong. This tracing back is a bit tricky. Actually, when you draw this line, right, we should trace it back immediately. And here too. Okay, so I've not done it right. So I'm a bit off, but yes, this is where your image is formed. Okay, let me do it properly. I can't let it be, at least to show you guys. Okay, I'm actually manipulating. It's not exact. Let me see if that is okay. Oh, no, I need not manipulate. I get the answer. Okay, I got the answer without. Huh. No, I got the answer actually. I did the angles right, so makes sense. So they'll be in the same line. So this is where your image is seen. Okay, as simple as this. So whenever you have to know exactly where the image is seen, all you have to do is look at the reflected ray. If they appear to come from somewhere, or if they're going to meet somewhere, that's where the image is seen. As simple as that. Okay, so I'll just do one last step to show you guys they're in sync. So this pretty much looks 90-degree, or anyways, if you guys do it on your own, you can use compass and measure it out. That will be the 90. This is where the image is seen. Let me label it. Protractor is off. Okay, so this is your object. That's your image, right? So when do we see something? When the light bounces off from that, or it itself is a source of light. So in this case, we have seen bounced off light kind of scenario. So we are able to see image inside the mirror. It appears to be there, right? Now, so we pretty much saw this. So there are a few things that we need to understand over here. Solid line and dashed line. So we saw solid lines and I used dashed line over here. What do they represent? Solid line by default, okay, in ray diagrams, this is known as a ray diagram, right? We are tracing rays, so this is your ray diagram. A solid line represents actual path of the ray. Okay, so this is the actual path of the ray, is it not? While your dashed line, right, all this, this is something which is behind the mirror. There's nothing actually behind the mirror, is it not? The object is not actually behind the mirror. So that's your imaginary path of the rays. Okay. So imaginary path of a ray. So this is something that you guys need to know. So solid line represents actual path, while your dashed line represents imaginary path. Now, to summarize, how to find the location of an image formation. To begin with, we need at least 2 rays minimum. We can have more than that to find the location of an image formation. The point where the reflected rays meet, that is solid line meets, or appear to come from. So in this case, they appear to come from, is it not? They are diverging. So these 2 rays will not meet any point of time. So they appear to come from. Sometimes the solid lines, that is the actual path of a ray, they meet. So that is something that we're going to see a lot in the future, is where the image is formed. Okay, so this is something, it's a small note, but again, this you will see that it'll be used a lot and you'll get familiar with this. Okay, but yes, solid line and dashed line represents actual path and imaginary path is something that you guys have to keep in mind. So this is a small introduction to the things that we're going to see in the future. So please write the heading. Right, and all of this has to be written.